one of the latest things that's going on is, how many of you heard of a terminator gene? You heard of a terminator gene? Okay, there's two guys. You know what is a terminator gene? It's a gene that they put in the seed, and then the crop will grow. At the end of the season, it's going to produce the yield. And if you take that seed from your corn or from your soybean, and you put that seed in the ground, that seed is not going to grow. You know, it kills the germ. It kills, you know, so to speak, you know, kills the germ. Basically, prevents seed from germinating. And one company in the United States tried to push that, and I tried to push that under the umbrella that, hey, by this way, we're protecting our intellectual property. So that means, you know, that the producers that grow soybeans, they cannot take their seeds and plant them or replant them next year. But then the opponents of the whole deal were saying, wait a minute, you're putting that gene in. That means you're directly controlling the food production. You know, if you want to produce the food, that means, you know, and we cannot save our own seeds. They're directly controlling the food production. So anyway, so I guess that's kind of the story related to you know, how it's owned by the you know, the seed industry, the pesticides industry, and so forth. And obviously, I went through economic benefits, and pretty much, you know, these companies are out there. It's literally a silent war. Maybe I'm not using the most politically correct term, but it is a silent war, you know, for market control. You know, who is going to control markets and where and everything. So that's kind of the at least from my perspective. And if you read some of my publications on this issue, you know, that's all covered in there. Right now in the United States, I'm talking about soybean or producers. When a soybean producer buys the seed, he has to sign the contract. In fact, the company that sells all this has a huge computer database about each and every farmer, in the United States. They know, literally, you know, how many acres of their seed is planted on each and every farm in the United States. So that farmer, if he comes back next year and he plants, he saves the seed and plants his seed there, the company can come in and ask him, okay, you know, what kind of seeds did you plant there? And if he says, oh, I planted your seeds, and they're going to ask him, okay, your name is not in our database. Nowadays, if an American farmer wants to plant conventional soybeans, that means non-GMO, non-Roundup ready. If he wants to plant that, good luck. He cannot find it. They don't sell it. They sell it only on a small, limited acres. They're directly controlling that market. So the terminator gene issue in the United States right now doesn't exist. So I want to make sure that I was not misunderstood there. It does not exist. But they tried to push it, they didn't succeed. Now I'm hearing that they're trying to do it again. I have producers in my part of Nebraska who want to plant conventional soybeans, and they cannot find seeds. There's very limited number of seeds over there. I perfectly understand why the company wants to protect, you know, but I'm saying if we allow them to do that, they are directly protecting their patent. I understand that. But indirectly, can't we say that in a way they could control a food production? We cannot?
That's a political statement.
Right, it could be a political statement.
Yes.
Right, I would agree with that. It could be a political statement.
It is.
Right. Okay, I agree with that. All right, let's go on. What are some of the concerns? What are some of the concerns that we are seeing with the widespread use of herbicide-tolerant crops? Obviously, they have a gene that is going to help them, you know, withstand application of certain herbicides. So, with the widespread use of glyphosate, and these are some of the crops that I listed in there, those crops are sprayed at least, you know, once or twice. In some cases, maybe 3 times. If you're in the parts of the United States when it's warmer and it rains more, you get more flashes of weeds and everything. So we do have literally a great selection pressure. You know, you're using the same herbicides over and over and over, and we're beginning to see problems with this with the issue of selection pressure, anywhere from weed shifts to weed resistance. And basically, glyphosate is a fantastic herbicide. It's probably 1 in 100-year discovery. You know, it's a fantastic herbicide, and it's extremely inexpensive to make. You know, relative to many other herbicides over there. So before introduction of Roundup Ready crops, there were about 3 species that had cases of glyphosate resistance. Now, after we've been using this product, you know, on so many acres, not just in the United States, we're talking about South America, especially countries like Argentina. I've been in Argentina quite a few times. I've been in Brazil there, had a project with some colleagues in Brazil. Brazil was a non-GMO up to about 4 years ago or so. Argentina is pretty much a copycat of U.S. agricultural system in terms of using GMO crops, especially Roundup Ready crops. So basically, we have now, since introduction of Roundup Ready technology, about 15 different species that develop resistance. 15 different species that develop resistance. And I don't need to go through each and every species. Probably many of these names don't mean much to you guys. So if we look just in the United States, we had only one species. It was a ryegrass in California that had a case of glyphosate resistance. And now, after we've been using glyphosate on 100+ million acres over last 10 years or so, you know, we have about 10 different wheat species that develop resistance to this herbicide. So here's the example of a single selection pressure, and this comes from those fields where the farmers were growing conventional soybean, and then they switched to Roundup Ready soybeans, and they've been using Roundup a couple, 3 times a year. Usually they don't use any other herbicides. Like I said at the beginning, the technology is really simple to use, and then so they've been just spraying this over and over, and that's the case of the 10 different species. Basically, in the last 5 or 6 years, we've been adding every year. We would add another species, to this list. Here are some of the pictures for those of you who like geography or so. Nebraska is this state right here in the middle, that red state there, and that's where I live and work. The areas where Roundup Ready crops are grown is pretty much what we call the middle portion of the United States, going, you know, up across and then coming south. Obviously, you know, we have the mountains out here, and Roundup Ready crops are not that very common in California, simply because of the different agriculture in there. California has got a beautiful climate and everything, so they're growing much more of a higher value crops as opposed to Roundup Ready crops. And then also there's some issues with the drift of herbicides and everything. So, but anyway, these are some of the pictures where we've seen cases of glyphosate resistance. Even some data on individual farms. Like I said, many of these companies have huge databases about where is the resistance and how is it occurring and what. And there are some examples here. Water hemp resistant in Missouri. I mean, these are the fields where these plants are surviving. These plants are surviving as much as 8x rate, 8 times of the label rate. You know, they're not controlling it. Here's an example of the plants that survived. You know, they killed a portion of the plant, but they didn't kill the plant completely, and you get new branches developing. So this is pretty much a topic that's related to you know, a lot of people who really care about weed science, but the rest of you, just to give you a picture that, you know, glyphosate resistant is real. In some other parts of the country, lamb's quarter is one of the beautiful Schenopodium species. In some of the states, you know, this is even down on the county level, and where in what counties we have glyphosate resistant. Maresdale, it's one of those species. Again, another species. This is giant ragweed, which is one of the ambrosia species, Ambrosia trifida here. This is the newest glyphosate-resistant species. It's called the Palmer amaranth, or Amaranthus palmeri is the Latin name. And this is actually becoming a big issue in some parts of the United States, namely, obviously, cotton growing areas, but namely parts of Georgia, South Carolina, and Mississippi. And basically, let me tell you why they're making a really big deal about this weed. What has happened in the last 10 years, these companies purchased most of the seed growing companies or seed producing companies in the cotton production areas. And then the growers were planting Roundup Ready cotton for the last 10 years. In those 10 years, all the other parts of the pesticides industry or the herbicides industry, they could not compete in the price with the Roundup Ready technology. So a lot of those businesses disappeared completely. There's a perfect example of a competition. And they say competition is good and that's fine. But the issue right now is that the Roundup Ready technology on cotton, and here's the level of resistance, 9x. These are the fields in some of the areas where the guys typically don't grow any other crop because of the weather conditions and then the economic factors and everything. They grow cotton in monoculture. So they put all of their eggs in one basket called Roundup Ready cotton. That basket is not delivering anymore. It's not performing anymore. And so this is where the risk comes in, where we trust one technology too much. And here's the problem now. These producers, you know what they're doing in the fields like this? They're going back to hoeing. They're hiring physical laborers to go out and hoe because they don't really have good herbicides to take care of some of the problems. So the issue with Roundup, with the Palmer amaranth issue in the United States, actually about 3 weeks ago, I came back from Orlando, from Florida. We have a National Weed Science Society meeting, and there was a symposium. There was about a half a dozen to a dozen topics and presentations just related to this problem. In cotton production when the Roundup Ready cotton is planted, and the Roundup controls all kinds of other species, but it doesn't control this species. So I asked some of the people there, okay, so these producers, do they have a chance to plant non-Roundup Ready cotton? The guy says no. I said, okay. I said, is anybody asking a question? Why am I paying for a tech fee for Roundup Ready cotton if Roundup doesn't really control my problem weeds in there? And the response for that was that, yeah, people are asking, but the company is not giving them any money back or anything. They're saying that the Roundup still control other species. So for a situation like this, what do you do in that situation? And that's where the silence is. Nobody's really saying anything. Just a few more shots. The same type of a weed species. This Palmer amaranth is a prolific seed producer. Individual plants can produce easily a couple 100,000 seeds. You can imagine how many millions of seeds is in that particular field. What we are seeing definitely is a weed shift. Glyphosate, like I said earlier, it's a fantastic chemical. It doesn't have a residual activity. And if they're using it just for a couple, 3 times in the season, they're not adding other modes of actions and everything. And when you look at the whole system, the weed species that we are seeing a shift to are the winter annuals. Those are the ones that germinate in the fall. And they'll grow for a little bit, they'll overwinter, and in the springtime, they're going to start growing relatively early in the season. Sometimes as soon as the snow melts, they're going to start growing. And by the time by the time, and here's the list of some of those species that I have in there. You know, we have about a half a dozen to a dozen different weed species that are literally exploded in the last 10, or I would say not 10, in the last 6 years. And in the springtime, because of the weather conditions in Nebraska, we would have relatively warm days, but we will have cold nights. And the glyphosate is a systemic herbicide that needs to be cycled throughout the plants, and the plants needs to be, more or less actively growing. It doesn't really grow during night because of the cool nights and everything, or actually I should say it doesn't cycle it during because of the cool nights. So we are having a poor control of these species. So in many cases, when this problem started, I could literally drive around Nebraska and say, this is Roundup Ready field, this is conventional field. Nowadays, it's really hard to say which one is which, because of most of them are Roundup Ready. But these are some pictures that are at least about 5-6 years old, where you could see this is typically the way they grow Roundup Ready soybeans. They will either till the field or not do anything to it if it's a no-till situation. They'll plant the soybean, and in many cases they may have circles of winter annual weeds in there. They'll plant the soybean right in the stand of winter annuals, and they'll wait for soybeans to come up. By that time, the winter annuals are pretty big. So there's some issues about the way this technology is managed. It's managed, so we end up with the situations like this, and then they go in and try to kill these weeds with one shot of glyphosate. In fact, this field was sprayed. You can see, for those of you who know symptomatology of glyphosate, you can see this yellowing on the newest leaves. The glyphosate inhibits the shrimp acid pathway, which is the amino acid production, and you get a starvation of the youngest leaf because the young leaf needs the most food for growth, and you starve these young leaves, and eventually you starve the whole plant. So, like I said, that's so basically, how do you deal with this situation? You have to add another chemical now. So you're not just spraying glyphosate and paying a tech fee for glyphosate. You have to add another herbicide, which also adds to that cost. The weed control. That's not the end of the story. Speaking of the shift of weed species, we have shift of weed species, and I forgot to mention that earlier, from two standpoints. One was the winter annuals, the shift in time of occurrence, and another one is the shift to tougher, what I call, for a lack of a better term, I call it tougher weed species. And these are the weed species. The list was compiled in Nebraska. This is Nebraska data. Because of such a widespread use of GMO crops, it's very hard to find pure conventional seeds, especially for crops that are canola and soybean. And canola is not widespread, it's in certain pockets. Actually, what I'm referring here is the colleague from Manitoba, Canada, René Benecker, that they published some material where the weed scientists work with the canola breeder at the University of Manitoba. Manitoba is just straight north of, you have Nebraska, you have South Dakota, North Dakota, and Manitoba straight into Canada. They grow a lot of canolas out there, and they're finding, according to their canola breeder, the guy says that every one of their varieties will have traces of Roundup Ready gene in it, or a Liberty Link gene in it, or a Clearfield, because those are the three different types of canolas that are being grown over there. So these canola producers, if they want to sell non-GMO canola to European market or the Japanese market, they're having a hard time. Again, this is all related to gene escape issues. I mentioned earlier, organically grown and gene issues there. All right, so here is another question, and this would be more some can call it hypothetical, so I can call it political, however you want. There are people there that are saying, all right, we're putting all these genes into these crops. The companies are selling and benefiting from this technology. You know, who is really responsible for, any consequences down the road? Do we really know? Is there any consequences or not? You know, right now, there's very limited information in there. Maybe it is limited because we're not finding any consequences and everything. But this is where it becomes a legislative issues in some countries. In fact, some of the countries are saying, okay, if the company can provide us some kind of data or some kind of guarantees, but in a way they're also saying, how do you have the guarantees for some of these things? So it's becoming a legislative issue and it's becoming a political issue. And I guess I'm not going to say anything more than that. You know, that's kind of all open for interpretation. It was mentioned earlier, if you put a terminator gene in it, you're not going to have a volunteer corn. That's definitely a benefit of that. Like right now, I'm saying volunteer crop, not volunteer corn, volunteer crop. Right now, what we're saying in my state, typical crop rotation in Nebraska is soybean and corn. It's just the two crops. It's not much of a rotation, quite frankly. Oh, now we have Roundup Ready soybeans and about good, 90 and plus % acres. We have Roundup Ready corn, and about, in some parts of the state, we may have only 20% of Roundup Ready. In some other parts, might be 60 or 70%. It just depends where you are. It's mostly related to like what kind of weed problems you have. There's some parts of Nebraska where we have a hard time controlling certain weed species. With the conventional herbicides, and glyphosate helps a little bit. So in those areas we have a higher % of Roundup Ready corn. But in either case, if you have a rotation of 2 Roundup Ready crops and you're using Roundup every year, you're going to have a lot of volunteers, and that also requires another set of herbicides and the cost of weed control and everything. Okay. What are some? I think I have about 2 or 3 slides and I'm done. I think it took me a little longer than what I expected. What are some of the future predictions? This is my own interpretation. You can call it my own fantasies, however you want. This is what I'm saying based on what I'm seeing in the United States and working with some of these issues. I talked earlier about that multi-gene. I showed you the examples of a 3, 4, and it's going to be up to 8, and who knows down the road where we're going to have more than 8 or so. Another thing that we're seeing from the strictly weed control standpoint, up to the last couple of years, a lot of farmers were using just glyphosate. Now in those fields where we have glyphosate-resistant weeds, they have to add another herbicides and everything. That's why I call it's the beginning of the end of the glyphosate alone era. And then we're seeing now some companies are coming up with these pre-mixes so that you have glyphosate inside and you have another herbicides, another mode of actions. And then some of these companies pretty much conquered North American market. They conquered a lot of the South American market, at least the main crop growing areas. They're pushing this now into China. They're pushing it into Australia or so, and they're pushing it, I've been told, in some parts of Eastern Europe and including European Union. Anyway, and then I think this is pretty much the last slide of my presentation, which kind of combines all of this more from the applied weed control standpoint. People are asking, all right, we've been with these crops now for 10 years. Definitely there were some benefits. Definitely we're seeing problems. Are we going to be seeing more problems? What is going to happen there? So, some are saying, yeah, the technology helped. some are saying, wait a minute, yeah, it helped in the beginning. Now we're seeing all these issues. We're paying for tech fee. Now we have to tank mix other products in it. That all adds up to the cost and everything. So yeah, it helped us for whatever number of years. But you know, we're now in terms of really benefit. And the people are saying, who is really benefiting from this? You know, the farmer was paying for it earlier. It had a little benefit in the beginning, you know, in terms of money, savings and everything. Now we're seeing all these problems. The price of glyphosate increased. You know, the farmer is paying for it again. So again, I'm trying to paint you a picture here. You know, what is going on right now when it comes down to this issues. And the scariest part in this the whole picture for me, as being a university professor and observing what's going on over there, we're seeing a generation of producers in the United States that when it comes down to weed control, you know, they've been growing together with this Roundup Ready system for the last 10 years. And when you want to talk to them about weed control, the first thing that comes to their mind is Roundup, because that's what their father was doing for the last 10 years. They don't really think in the concept of integrated pest management or a concept of integrated weed management. You know, and I teach a class, it's a graduate level class on integrated weed management, and that's the field that I'm getting from this younger generation. You know, and that's where, you know, one of the scariest parts for me, you know, like going with this technology on such a large scale. Quite frankly, you know, if United States producers use Roundup Ready soybeans only, and then they grew conventional corn and conventional, you know, canola or some other conventional crops, I guarantee you that we would not have 10 glyphosate resistant weed species in the United States, because they come primarily as a result of the repeated use and the selection pressure. And basically by using these other crops, basically using other tools of weed control, in a way, you know, they would have worked with the concept of integrated weed management. And that's why I'm asking here, do we need an integrated weed management? And I'm saying yes, yes we do. And I think with that, it took me about an hour and 10 minutes or so. I think I'm done. Yeah, it just doesn't want to advance, or it's done.